Nikolai Koldunov, and today I'm gonna show you how to configure fmesh, the simple mesh generator for regional FESOM2 setups. I hope that you went already through the installation and download some necessary data and maybe even already run some examples. But today I want to concentrate on configuring the thing and mostly on the setting up the regions with increased resolution that you should set up in Google Earth, and also on looking at the data at the end. So here is configuration file for fmesh. You have some very basic parameters here, like path to the topography file, which has to be airtopo for now, and number of latitudes and longitudes for the two-dimensional representation of your resolution that you actually give to the jigsaw, and jigsaw is the mesh generator that is used for basically generating the mesh. So the higher your resolution, if you like put here like 10 and 10, the better will be your final mesh, but it will of course take longer to compute. So in this case I put very low resolution, just 1 degree, and the base resolution is the resolution that your base mesh will have. In this case is 300. So initially the jigsaw will cover, well, not the jigsaw, but I mean the mesh resolution preparation routines will cover your whole globe with 300 kilometer resolution, and then you have several options to refine it. So this 300 kilometer, and again I put 300 in order to make things faster, can be further modified for the base resolution by doing do Mercator refinement true, and this will give you a possibility to actually refine your resolution with latitude. But at some point the resolution, of course, in the polar regions will become pretty low, pretty high, and in this case you would like to put some boundary where your resolution will become also constant. So in this case at 77 north we put 25 kilometer resolution, so that our resolution doesn't really become very low close to the poles. Same thing can be done for the southern boundary. Another thing that you can do is to refine your resolution along coastlines, and here are also some parameters that are available for you. That takes some time, and I usually don't do this, but some people like to refine their resolution also along the coastlines. But the most important thing that I would like to concentrate today is these regions. So regions is the further modification of your base resolution that allow you to make some regional setups, and you have to define these regions as KML files, and this you can easily create in Google Earth. So imagine that we would like to create some Kara-C setup, right? So this is Google Earth. We just open it, zoom to the Kara-C, and then start to create our polygons that will define the regions with our increased resolution. So we open the ruler here, and we select the path, which is for whatever reason on Mac is blank when it's selected, but believe me, so here is a path, and we start to kind of define the region where we would like to have high resolution. So you can be very precise, but I don't have to be super precise here. And you don't finish the line, so you don't kind of put the last point to the first point, because this is what will be done by fmesh automatically, right? So you're happy with this region, you click save, and then you put inner path. Okay, so another thing that you have to define is the outer path, and we do it in the same way. So we just open the ruler and we define the outer polygon let's define it like this. Let's put it here and here. So what the outer polygon is defining. So the outer polygon is the boundary where your resolution comes back to the base resolution. And in between these two polygons, your resolution will be linearly changing from the high resolution, possibly high resolution inside, and the low resolution outside, right? So so it defines some smoother transition between inner polygon and the outer and your base resolution, right? So save it, then outer path, okay, and you have to then save it. Save place as, and very important that you save it not as KMZ but as KML file, right? So I already have one, and I save it and overwrite it, replace. So now I have a Kara C KML file on my path. So what I can do next, I just add another region. So we already have a Denmark Strait and Gibraltar Strait from the test setup, and we can add here another one. So we can put here Kara C. So this is just a title, so it shouldn't be like with underscore or something. And this one should be a path to your KML file. So should be precise, of course. Kara C KML. So the resolution, let's put here 5 kilometer resolution, and precision is the number of divisions that each of these lines will be further divided in two in order to define the this linear decrease in resolution better, right? So that we don't define the result. So if we have a point here and point here, so that we don't linearly interpolate between this, but we linearly interpolate between these places. For this, we have to have some points here, right? So that's the precision. Okay, we set it up. We have this CarC, and then we will run the fmesh, and I will run not the fmesh itself, but I will run the script that is called test.sh, but it's basically the same as running python fmesh.py, but before that I just remove some old files that we save in case that something goes wrong with fmesh. So right now I just basically remove the old stuff and run the fmesh. So okay, so Denmark and Gibraltar is over. So CarC now takes some time because it's 5 kilometer resolution in 300 kilometer resolution base mesh. So this is something that I would definitely not recommend anyone to use in production, of course, because it doesn't really make too much sense. But for demonstration purposes, I think it's fine, so that it's relatively fast. So now Jigsaw is working. So Jigsaw generates the base triangular mesh that covers the whole globe, and try to optimize the placement of the triangles. Okay, so it's over, and now we open the global topography, and now we'll try to cut the land basically, and deleting the loose triangles, hanging triangles, and that's it. So what we have here, we have the classical FESOM mesh files, but we also have something that is called _result.vtk. So it's a VTK file that can be opened in the ParaView. Oh, I have here a spoiler, so let's remove it. So imagine that you don't have anything, so even this sphere, just here for a case. So you can, in ParaView, you can open the result VTK, and it will look like this. So you have to press this little I to make it visible. So not very impressive now. Let's change the representation from surface to surface with edges. So now it's a little bit better. You can zoom in, zoom out like this if you hold the right button, right mouse button. So um, doing this is left, you're holding the left mouse button, and doing that you're holding the right mouse button, and you can see that we have the 5 kilometer resolution in the Barents Sea, right? Well, in the Barents Sea, in the Kara Sea, right? And the rest of the Arctic Ocean is pretty pretty have pretty low resolution because we have a base resolution of 300. Well, in this on the north we have to have a 25 kilometer resolution, right? So no, we have actually everywhere 300 meters because I didn't put the refinement with latitude, so it's everywhere 300 kilometers, so it's very low resolution. Okay, but that's a little bit ugly because we have these holes in the earth, and that's not very nice to look at. So the way to fix it, you can add the sphere inside of your globe in order to make it well, I mean, the void inside of our globe. So for this, you have to go to sources, then go alphabetical, sphere, so you get a new sphere. You put the radius of this sphere to 6,371, and you put some better resolution here, like 20 and 20, and don't forget to apply. And you have a sphere that kind of fills the void, right? So this is Greenland, by the way, if you didn't recognize it. So and that's basically it. So you can now zoom in and don't be annoyed by the fact that your globe is have a really big hole inside, and analyze your resolution and find if it's nice or not. So this is our inner region, and this is our outer the boundaries of our outer region. Yeah. So with this, I think I will leave you, and yeah, happy creating new meshes for you.